Hello everyone, this is Andrew Ide. I'm with Kent Scientific Corporation. Today we're going to be talking about right-sizing small animal anesthesia, particularly for rats and mice and other small laboratory rodents. If you have any questions throughout the presentation, feel free to type them in, and we'll either try to answer as many as we can at the end of the program, or if there's some good ones that come in, we'll try to discuss them a little bit during the program. Anesthesia has been used for the last couple hundred years now, and there ends up being generally two types of anesthesia: the gas anesthesia or inhalation anesthesia and injectable anesthesia. Gas anesthesia has advantages over injectables because it's pretty easy to use. You have better control over depth and duration. It's very easy to adjust the concentration almost instantaneously on gas anesthesia. Animals, particularly small animals, don't really metabolize the gas anesthesia that much. It stays in their bloodstream, and it is expelled through the lungs. Most of it is expelled through the lungs, so it's easy for the animal to recover, and it doesn't have to worry about the liver or other organs to metabolize the inhaled anesthetics. Inhaled anesthetics are safer for the animal and increase the chance of successful outcomes, which again, it's because of the fast induction and the fast recovery for gas anesthesia. The problems with gas anesthesia are a few. One of the things is typically you need some big equipment to vaporize the anesthetic correctly, and it takes time to set it up to make sure it's all working. Sometimes there's a steep learning curve. A lot of people feel that gas anesthesia is somewhat magical in what it does, and so they're kind of afraid of it. And you have to make sure that your multiple components are working well together. Make sure that the vaporizer works with the flow meter and the gas source, and bringing it down to the animal. There's also using the large equipment that people typically use. There's a big risk of anesthetic exposure to the researcher and staff, because a lot of anesthetic is wasted and often is blown off just into the room. And typically it requires a compressed gas source of some type, whether it's compressed air or oxygen source to make the vaporizer work. Traditional small anesthesia systems typically are designed for humans and larger species, such as horses. The same vaporizer that people are using on a mouse can be used on a horse or a larger animal. It's all mechanical. The standard vaporizer that's made, besides requiring large airflows, typically weighs, as it says here, 35 pounds or 30 pounds, and has a large footprint on the lab bench. Even a tabletop stand will have a fairly large footprint. The weight is caused by a heat sink that's built into the vaporizer, because as the anesthetic evaporates, it draws energy from the environment being the vaporizer, which drops the temperature of the vaporizer, so it needs a big heat sink of solid metal to try to control that temperature drop. And also the problem with vaporizers, typical vaporizers, is that they are agent specific. So a halothane vaporizer, which people really don't use anymore, can't be used for anything else. So it just has to be, if it can be retooled, it might be able to be reworked, it might be able to be used. But if you're using a sevoflurane vaporizer, it can't be used for isoflurane. And typically a high oxygen flow is required. I just had a an inquiry come in just yesterday from England, in which a person, for anesthetizing a mouse, the researcher was using 2.5 liters of oxygen per minute at 2% isoflurane concentration. That's quite a bit of gas for a mouse. Right sizing, we continue. So typically you might have this type of setup for a traditional anesthesia setup. You'll have, if you're ventilating the animal, you'll have a ventilator, you'll have a, if you're doing pulse oximetry, you would have maybe a computer with a pulse oximeter on the mouse, oxygen tank, and it ends up being a rather large setup, particularly in cramped laboratory spaces. So there are other choices out there. One is the Somno Suite, which we provide to the research community, Kent Scientific. Small animal anesthesia. You will have to, just as a side note, you will have to forgive me because I'm the substitute speaker, so I'm not probably as smooth as the regular presenter, but I am the designer of these products, so I do have a little bit of background with them. The Somno Suite design is based on the physiological characteristics of rats and mice. The small footprint is 6 pounds or less compared to 30 pounds. It's the same unit can use either isoflurane or sevoflurane, or if there's another gas, a liquid anesthetic, all we need to know is the molecular weight, and we can put it into the program and use that. It requires low flow and low oxygen use and is safer for the user. There was Syracuse University has six of these in one room, and they had been using a traditional vaporizer setup and were having problems with anesthetic buildup in the room and exposure to the researchers. They purchased 6 of these for their student lab, and we were told that when their control people came in and tested for anesthetic exposure, they couldn't find any significant levels of it with 6 running. So we were pleased to hear that. The system works the way the system works is based with a syringe-driven anesthetic going into a warmed, heated vaporizer block. So the unit can take anywhere from 100 microliters up to a 10 microliter gas-tight syringe, and the injection goes into the warming. We call it the integrated digital vaporizer, which injects the isoflurane or the sevoflurane into the warming block. The warming block has an active heater on it, electronic heater on the bottom, and is tempered with a thermostat, or actually a temperature sensor that goes into the microcontroller unit so that we can accurately control the temperature to overcome the effects of the overcome the effects of evaporation, drawing energy from the system. It's also has a dial control, so it feels similar to a standard vaporizer instead of trying to use a digital type of control. So with the dial, you can dial up anywhere from 0 to 5% for isoflurane and 0 to 8% for sevoflurane. The unit also is capable, it has an internal pump, so it can use either room air or compressed gas. The arrow here shows the line, the inspiratory line to an animal, and then the expiratory line is for scavenging to a charcoal canister or to a evacuation line. On the back, there's the compressed gas inlet, and there's the outlet to the scavenging filter. And there's also the room gas inlet. The integrated display shows the volume of anesthetic remaining. It shows the anesthetic percent setting. And it shows the flow meter. We call it the minute volume because one of the modules that can be put in here is a ventilator, and so in a ventilator we use minute volume as a term for flow rate because it's the amount of air per minute going out or gas going out. So we use this a standard term of minute volume. It also shows history, the last 5 readings. You can also save data to an internal memory. And then dump that, bring the unit afterwards to a computer and dump the data to a computer. There's also alarms in the system. This photograph gives a small illustration of what they would look like with a mouse using a nose cone with a rubber seal on it. The alarms can be set for a low anesthetic level. It can be set for too high of a flow rate, or almost anything that you want them to. Any parameter that's inside of the unit that the unit is detecting can be set. Tubing connections, you can go to an intubation tube. If the ventilator is installed, you can go to a nose cone for the standard vaporizer and an induction chamber. Typically, I like to say that you'll use less anesthesia in a mouse during a full 4-hour experiment than you would filling a funnel-filled standard vaporizer. So typically, we use about a ½ ml, anywhere from 0.3 to 0.5 mLs per hour to anesthetize a mouse. And a standard vaporizer uses much, much more than that, even 10 times or more. Vital signs monitoring during anesthesia is particularly critical. It helps gauging the depth of anesthesia and maintaining the animal safety, preserving the validity of the experimental data. The NIH guide for the care and use of laboratory animals recommends that pulse oximetry be used to determine the levels of the anesthesia of the animal. Excuse me for stumbling over myself. As I said, I'm the backup speaker. Careful surgical monitoring and timely attention to problems increase the likelihood of, should decrease the likelihood of successful surgical outcome. The effects of the anesthesia, of the anesthetic. But one thing we know is that the anesthetic typically reduce heart rate. So 1% isoflurane does a 24% drop, and 2% does a 38% drop. And some of the other anesthetics also have even more significant drops in heart rate. Another area of concern is the depth of anesthesia. The depth of anesthesia must be maintained at the proper level, and to do this you would to induce the animal so the animal goes down deep enough, and then getting the animal on the nose cone, or intubating the animal afterwards, and to make sure that the animal stays down through the whole surgical procedure. Now, there are a few things that people use: a toe pinch on an animal to see if there's a reflex, to see if there's a type of eye reflex on the animal. The one I like the best for doing light anesthesia on our mice is the tail curl. we found that if the animal is getting too light when we're doing our testing, their tail, the first thing that the animal starts doing is their tail starts curling up. It's very interesting. So it starts getting tense and it's curling up, and then when we give it a little bit more anesthesia, the tail goes down flat again. So vital signs monitoring is quite important to help in making sure that your data is good, because if the animal is out of its normal physiologic ranges, then the body goes into other reactions. So the heart rate and respiratory rate may increase if the anesthetic becomes too light. Also, the heart rate and breathing might increase somewhat if the oxygen concentration for the animal is too low. Vital signs monitoring provides an objective measurement of the reading, besides just a subjective reading of the toe pinch or the tail curl, things like that. Then you have procedure-specific requirements on things to consider. In addition to the effects of the anesthetic, how will your procedure alter the animal's physiological state? Anesthesia causes hypothermia because of vasodilation. So it's really important to maintain the animal on a warming pad. And the surgery, if your surgery requires a long time with the animal's body cavity open, then there's a lot of evaporation that can occur in the body cavity. There's a lot of evaporation from the body cavity of liquid water evaporation, which then cools down, dries out or desiccates and cools down the animal's core temperature. Where are we here? Next. And then what does your study protocol involve? Are you doing survival surgery? Obviously, if you're doing survival surgery, you have to be much more careful on the way you're treating the animal, so that the animal will have a better chance of survival from the surgery. Also, anesthetizing multiple times. You want the animal to make sure that they're metabolizing the anesthetic well. And also the cost of the animal. The animals will be expensive animals. You want to make sure are done well and are very well taken care of. And then the IACUC guidelines and recommendations are also very important, which brings into to reduce the number of animals and to refine your research, particularly where we're involved here. We read this before a little bit on the NIH guide for care and use of laboratory animals, suggesting that for anesthesia, delivery precision vaporizers and monitoring equipment should be used, and which is why we're discussing this today. Pulse oximetry and such. Monitoring animals under anesthesia. There's two ways of monitoring their vital signs. One would be invasive monitoring, and the other way would be non-invasive. Invasive monitoring, it takes a much higher level of skill. Typically, if you're going to be using a telemetry device, the telemetry device requires a very drastic surgical procedure just to implant the device, and which has its own mortality rate. And then we need to also, you also have the high cost of the equipment. Telemetry devices are rather costly to surgically implant, and then they don't last that long. And the other option would be to have a direct dwelling arterial cannula for monitoring blood pressure. Non-invasive monitoring we prefer. Does not require implanting a device. It is less expensive than telemetry and can be used on multiple animals. Advances in technology allow it to be quite accurate and consistent and reliable. So some of the parameters that you might be watching are temperature, which is probably the most important to maintain the animal at its core temperature. With this, the hypothermia is often, occurs as we discussed with the anesthesia. Surgery has evaporation of the animal. The body temperature should be maintained in the normal range. The best way of doing this is with a rectal probe and a feedback loop, otherwise known as a homeothermic blanket. We prefer systems that have, to maintain, for warming the animal, we prefer systems that actually use far infrared radiation instead of just a higher frequency type of radiation. In horse studies, it's been shown that the far infrared penetrates the body, penetrates up to 5 centimeters into the horse muscle. So if we bring that over to a mouse, the far infrared penetrates right through the body. It also has several other nice parameters, such as inducing the parasympathetic nervous system and increasing nitrous oxide production and such. And so it has some other beneficial parameters to the animal for the far infrared radiation. Mouse temperatures and different animal temperatures are here. Typically, we find that a mouse temperature needs to be, to work well, it needs to be 37 to 37.5. Next thing that is very important is oxygen saturation, because as the animal breathes, is under anesthesia, its respiration rate is also depressed. So as the animal breathes, then it's getting less minute volume and getting less air. So if the animal is breathing room air under gas anesthesia, it ends up gasping. The deeper it goes, it ends up gasping and decreasing its respiration rate, which is very critical to the animal. So oxygen is given to overcome this. If you're not measuring, so the pulse oximetry measures how much oxygen is carried in the blood. Oxygen saturation is determined by passing 2 wavelengths. And we can give a better, go into that deeper, but looking at our time and the things to cover, we don't need it to get into that too much. Pulse oximeter calculates the difference between the oxyhemoglobin and anoxyhemoglobin, and the newer pulse oximeters that are designed specifically for laboratory animals can go up to 900 beats per minute. A typical veterinary style pulse oximeter typically only goes up to 450 beats per minute. Also, the sensors that are used are specifically designed for the mouse. There are companies out there that have tried using human-sized sensors on a mouse, so it requires a good chunk of the animal to be used, so that to determine the pulse oximetry, the animal has to be shaved, and then the sensor applied to the thigh of the animal or to the neck of the animal, something that's typically as big as a finger. Other companies, other devices out there are actually specifically designed for the paw. The clip anesthesias, the clips, with a spring-loaded clip, you have to be careful, because over time the clip will cause, the continuous pressure will cause ischemia in the area. And since you're trying to measure the blood flow and the oxygen content of the blood flowing past the sensor, if the sensor is squeezing too tight, it's going to, the blood is going to go somewhere else. And so you have ischemia and you won't be able to pick up the reading. Other sensors, our sensors are designed for mouse paws, the Kent sensors, and I'm not trying to, when we looked at the system, we tried to do something that was definitely mouse specific. So the sensors are used on the paw. They are not, they do not have a spring. They have a little rubber band on the outside, but the rubber band can be used with or without the rubber band, and you can adjust the tension on them to get the right flow rate. And also the center is hollow and it closes around the outside so that the flow is channeled towards the middle of the paw, where the sensors are. The oxygen, if an animal is on room air during gas anesthesia particularly, the oxygen content can go as low as 80% because the animal is not breathing well, gasping and not having the proper minute volume. Typically, people will give oxygen then to the animal, and that overcomes the problem of low ventilation and brings the pulse oximetry or the blood oxygen content back up to 97 to 100%. So you have to be careful, and if you're not monitoring the pulse or the blood oxygen level, you know, what does that effect does that have on the animal's lungs? Marcel, the keynote speaker, has great information on all of that, being a veterinarian from UT San Antonio. So typically people will deliver supplemental oxygen, but there is a problem, particularly in long surgeries, with supplemental oxygen that we will get to in a few minutes. Also, a decrease in SpO2 might not be respiratory related, but it may be perfusion related also. That because of the vasodilation, there's the blood flow through the appendages aren't as great. So when you're looking at vital signs monitoring for the animal, you should have look at the whole animal and not just at one parameter. And I think alarms are beneficial, and systems typically cost around $5,000. Here's some SpO2 ranges, typically that are good for the animal. Another thing to monitor while if you're doing vital signs monitoring is heart rate. Pulse oximeter will give you heart rate. Heart rate measured in beats per minute. The heart rate will tend to increase as the depth of anesthesia decreases. Pulse oximetry sensors are able to calculate the heart rate by monitoring because it's measuring the pulses already. So typical heart rates from a few different laboratory animals. And as we've talked about, other two is respiration rate. Both heart rate and respiration rate are depressed. But you will find that under anesthesia, if the animal is on room air, it'll start gasping and the heart rate will go up because the organs are not getting enough oxygen. So when you do put the animal on 100% oxygen, the heart rate will go down and the breathing rate tends to go down also because the animal and the organs are not calling for the oxygen that's necessary. So respiratory rate is measured in breaths per minute. It can be visualized by watching the chest rise and fall, but it's a subjective measurement and it's not continuous. Anesthesia depresses the respiration rate, as we've talked about. Freely breathing subjects on room air can easily become hypoxic. We've talked about that. Subjects have irregular gasping breathing patterns, which we've mentioned, and oxygen can alleviate the hypoxia, but 100% oxygen is not a normal condition for the animal and can have some other effects, particularly for long anesthesias. So artificial ventilation, we feel, is a major component for well anesthetized animals and controlling the variables, the outside variables of the animals. because when you're doing surgery and for a particular study, you want to be able to control as many of the variables as you can so that the research can be reproducible. So artificial ventilation allows the animal to breathe at physiological rates, at normal rates. It allows the subject to breathe room air, so you don't have the complications of oxygen, particularly for long-term experiments. It allows the subject to breathe in a normal tidal volume range, excuse me. Things to look for with artificial ventilation, if you're trying to choose a ventilator, is get a ventilator that's pressure and volume controlled. Get one that has a PEEP with it. Get one that has side breath insertion. That is really important because as the animals who are ventilated for a long time, either under anesthesia or spontaneously breathing or ventilated, can have atelectic buildup, or they can become atelectic in their lungs. And so when you insert a side breath into the regular breathing pattern every so many breaths, that expands the lungs to a greater volume, redistributes the surfactant throughout the alveoli, and gives the animal a much more efficient breathing capability. Also, if the animal is lighter, have a ventilator that has an assist mode in it so that it detects when the animal is trying to inhale, and then it will give the animal a breath. And also, if you're doing imaging, you'll definitely want a ventilator that triggers and works with your imaging, your MRI machine or something like that. And make sure it has built-in safety parameters, like it can't do overpressure. Standard piston pumps type ventilators, the old type, with the piston pump going back and forth. A lot of people use those through the years, but they've never monitored the animal's airway pressure. So if a person dialed in the wrong tidal volume in the piston pump, the airway pressure would go way up and could often pop the lungs. So here are some typical breathing rates of animals. And lastly, something else that you can monitor would be blood pressure. The blood pressure obviously is the force against the artery walls. The blood pressure is recorded as two numbers, the systolic and diastolic pressures. And monitoring can be invasive or non-invasive. Invasive is done through catheterization or through telemetry, but it's continuous, which is nice about that. So you get a continuous waveform that you can monitor. Whereas the non-invasive blood pressure is measured through the tail. The animal's temperature has to be correct, so you have to really make sure that the animal is on a warming pad when you're trying to take their blood pressure non-invasively. The tail on a rat or mouse specifically are used for core temperature control. And a blood pressure reading can be taken every 30 to 45 seconds. And you can also get continuous heart rate from the pulse oximeter readings. There are different types of methods. The one that seems to be the oldest method is photoplethysmography. That's shining a light across the tail and trying to pick up the pulsations on the other side of the tail with a photosensor. People have used a piezo sensor or a strain gauge around the tail called piezoplethysmography. And the last one is the volume pressure recording technique. That is used with an additional sensing cuff on the tail to get accurate readings from the tail. The VPR cuff is actually used as pressurized and squeezes the blood out of the tail. And then when the blood flows back into the tail, the method mechanically integrates the blood coming in and gives accurate readings of systolic and diastolic pressure. Considerations when you're selecting a lab a monitoring system. Identify the parameters you think you'll need for the animal, the study, and the protocols. I have Cook protocols and guidelines. How much space are you going to need for all of this equipment? And consider the future use with animals or upgrading for different modules. Over here. Why wouldn't you monitor animals? Think about what's going on with the anesthetized animals on a cold lab bench and for several minutes with no oxygen. The body can go into a lot of other reactions from these things. The Somno Suite, as we talked about before, has additional modules that can be added to it, and none of these modules increase the footprint of the system. With the mouse vent, you can install automatic ventilator, which goes right inside the mouse vent chassis. Or you can install a mouse pulse oximeter, called the mouse set, and into the Somno Suite chassis. The ventilator, which is called the mouse vent, is both volume and pressure controlled. It's simple to set up. The system was designed to try to make it tremendously easy. The default ventilation pressure is 15 centimeters of water, which is a safety parameter. It dials in, so that's the maximum pressure that the animal will get. And then, using allometric formulas, the user just has to dial in the weight of the animal, and the formulas are used to determine what the respiration rate is and also the tidal volume and minute volume that the animal should be getting. Then other things that the mouse vent capabilities is that it has automatic sigh breath. You can dial in a sigh breath down to inserting a sigh breath every 10 breaths. The sigh breath is a breath that is at a higher pressure typically. So if you're ventilating at 15, you might have a sigh breath of 20 or 25 to expand the lungs periodically. Assisted ventilation, if the animal is spontaneously breathing, you can still give them, still have them intubated and give them a breath every so often. The triggering for the ventilation, for the assisted ventilation, occurs. It either waits for an animal to breathe, or if it doesn't receive a breath within a certain period of time, which the user can set, it will automatically give a breath to make sure that the animal is not expiring or dying. You can have remote triggering in or out, which is particularly important for imaging, and electronic PEEP. In this illustration, it shows that the PEEP here is at 2 centimeters of water. PEEP is the peak end expiratory pressure, which is used to keep the lungs inflated. That's particularly important if you're doing an open-chested surgery, because once you breach the intrapleural cavity where the lungs reside, then the lungs will collapse. The PEEP keeps the lungs from collapsing. We had a question here. From Murray Holm at CSU East Bay. He asked, is the Somno Suite system compatible with stereotaxic frames? Yes, it is. It can be used with any of the common stereotaxic frames that are out there. The ventilation, and even better on a stereotaxic frame, is having the animal ventilated, if I can add that. Integration of both ventilation and anesthesia in one device. So the important part about this, about either way, but besides using the standard using the Somno Suite as a standard vaporizer for delivering anesthesia to a spontaneously breathing animal, if you put the if you add the ventilator module to the Somno Suite, it will ventilate the animal or anesthetize the animal at even much lower concentrations than you use blowing air or blowing gas past the animal's nose. Because the animal is delivered, the anesthesia that's delivered or anesthetic that's delivered to the animal is only the amount that the animal is required to keep it under. And so the ventilator delivers a breath to the animal, but it goes through the vaporizer block, picks up just the amount of anesthesia, and then delivers that down the tube to the animal. So essentially you're vaporizing at the animal's nose, not somewhere distant, and then piping it through a ventilator to the animal. The system can also take a mouse stat that's built into it. So besides the ventilator, you can also install the pulse oximeter. The pulse oximeter will measure that slide didn't come out very well there, but it measures heart rate, perfusion, oxygen concentration, otherwise known as SpO2, and it'll measure respiration rate if there's a strong enough respiration rate on the paw. So there's two sensors that are available. There's the a little clip which has just the rubber band on the outside, a very lightweight rubber band on the outside, so it's not spring loaded, and the hinge is rather stiff so that you can position it, and it will stay there, but will not increase the pressure on the animal the way a spring sensor will. Or we have other sensors for special use sensors, which are essentially non-contact, which we call the annular sensors, which have just a hole through them. The one on the right is a 4mm sensor that slides over the animal's paw. Only the pulse. This is the only pulse oximeter that I know of that works on the animal's paw. Everything else is trying to use human-sized sensors on a mouse. Great. So we want to leave the last 15 minutes here, or anything for questions. We have a second question that came in. This is from Moira Hawley from the University of Lethbridge. The question is, to use the ventilator, does the animal need to be intubated? Yes, the animal does need to be intubated. The current techniques require the animal to be intubated. At Kent Scientific, we provide and other companies do too, but we provide a system that's provided, which is manufactured by a company called BioLite, which has a fiber optic illuminator that goes down the center of the endotrach tube, which makes it much, much easier. And they have a whole system for intubating the animal. We really feel that the intubation of the animal, particularly for longer procedures, is extremely important. Because of the effect on the animal and the effect of 100% oxygen on the animal. If we go back here to show you the unit better, the ventilator is built in underneath the display screen, and then all of the pneumatics are inside, and the air to the animal comes out the integrated digital vaporizer block, and then it returns through the other port. Are there any other questions? I think we have our presentation time. It's here. Well, we hope that the presentation was informative. It's the important part about the smaller anesthesia system is that it only uses what the animal needs instead of using human amounts of anesthetic and trying to just siphon off a little bit of that to deliver to the animal. Okay, we have a question from Russell Higbee from Sanofi, Pasteur Vax Design Corporation. How many different vapors may be used with the Somno Suite? Actually, any liquid anesthetic that will be vaporized that has a vapor temperature, a vaporization temperature over 30 could be used in the Somno Suite. The current unit is set up for both iso and sevoflurane, but as long as we know the molecular weight and the vaporization temperature, the Somno Suite does a molar calculation of the amount of air that's going out through the vaporizer block. And with that, we calculate the number of moles of the anesthetic that are needed to be delivered to the airstream to make a certain percentage. And then when we test that, we run that against a test, the test equipment, it is right on, it's dead on. The question, who can maintain this unit? Is Kent Scientific the only one that can service the unit? We are the only company. This is from, excuse me, Moya Holly again at Lethbridge. We are the only company that manufactures the Somno Suite. Yes, that's correct. We have them on the shelf all the time. But typically, the unit does not require calibration because it's all digitally calculated through the sensors and such. And the sensors are all pre-calibrated, the flow sensors and such, so they're reproducible. And the maintenance on it, you would annual maintenance requires that you replace the vaporization frit, which is just on the inside of the block, and which is a filter that we supply, but it's a sintered disc. This is from Russell Higbee from Sanofi again. Is it programmable by the end user? The system, the Somno Suite has a full menu system, and you can go into almost every parameter and set it. So the user can set the type of anesthesia, the size of the syringe, the temperature of the vaporizer block. You can determine whether you're going to turn the anesthesia system on or off if you want to. And such. So as far as the ventilator goes, all of that is settable. Even though we tried to make the ventilator simple, the ventilator, by entering just the animal's weight, the user can go in and adjust any parameter on the ventilator. We have a question from Pedro Fiera from FMUP. Can the ventilator data be inputted to some kind of software like LabChart? 80 Instruments, who makes Power Lab, was nice enough to make, and we worked with us, and we made a bridge so that we, excuse me, in our units we put in a LabChart interface, and so you can download a free from the Somno Suite and the Physio Suite and the Coda Monitor that Kent Scientific makes all have the LabChart interface. And LabChart will automatically connect to the devices and collect data from them. Question from Piero. We did that one. Okay. So, okay, so anyway, it's there. What do we have down here? I have another question, excuse me. This is from Murray Horn from CSU East Bay, and said, did I understand correctly that room air can be used as a method of administrating the gas? Sorry, the rest of the question is there any benefits? And I'm clicking on this, which is supposed to show me the full answer, but I don't know if the answer is longer than that. Okay, so room air can be used as administration of gas. Yes, the Somno Suite has a built-in air pump. It delivers gas or airflow rates up to 500 milliliters per minute. So you can switch just by going into the first menu system. I think it's the fourth menu selection down on the main menu. It determines how you're going to use it. And with a standard vaporizer, Somno Suite vaporizer, you can use compressed gas or room air. And if you're using room air, it uses the internal pump. Otherwise, it uses the compressed gas on the back. We recommend that the compressed gas be anywhere from 5 to 10 psi. If you only have a high pressure source, we do have a small drop-down regulator that can be used on the back. And you can also use the compressed gas to drive the ventilator, as well as the room air to drive the ventilator. What's the maximum length of time that the unit can be used for? Is it possible to refill the anesthetic in mid-string? Well, for a mouse, typically you can run a good 4 hours on 2 mLs of isoflurane. If you're using sevoflurane, which takes a higher percentage, it would be less than that. But for isoflurane, you can run like I said, 2 hours, 4 hours on 2 mLs, so about 0.5 mLs per hour. So if you put a 5 mL syringe in there, you could go almost 10 hours on it. We like to have the flow rate a little bit higher, and yes, you can fill it in midstream. You can pop what we recommend perhaps is to have a second syringe if you think you're going to have to fill it in midstream. Have a second syringe that's filled. Just pop the empty syringe out. You tell the unit to fill itself, which automatically moves the plunger block back to the filled position. Drop the new syringe in, connect the tubing to it, and you're ready to go. So another question from Matthew Rigel from University of Texas, I believe UT Southwestern. Vaporizer calibration is required of anesthetic machines at our institution. How is the calibration of your vaporizer? We use the, you have to excuse me, the questions aren't all coming through here beyond 2 lines, but I'll answer it the best I can. Okay, so I'm sorry, it's showing up down here. I'm new to the command here. Okay. What is your recommendation on how the unit is calibrated? We periodically calibrate the units or test the units for calibration with a Riken anesthesia monitor, which we purchased from a company called right, I forgot the name of the company. Well, anyway, it's a typical sensor that's used for calibrating vaporizers. Every time that we've done it, if we set it for 2.5% and we run it through the monitor, it's 2.5%. And we were doing that on the prototype units to make sure our math was correct. And the first time we ran it, it was that way. So because this is like calibrating an Excel spreadsheet, essentially. So what you can do is take the unit, set it for a certain value. The flow rates tend to be a little bit low for the Riken sensor, so you have to make sure that you use at a higher flow rate. And you can test it every year. but it's not required. The calibration, again, is like calibrating an Excel spreadsheet. So I don't know how you calibrate an Excel spreadsheet except trust that it's doing its mathematics correctly. Any other questions? Again, excuse me for being a little rough, but hopefully I've answered all of your questions. The system itself fits very well. We were at a presentation. I haven't seen Marcel's presentation this time, but we were at a presentation 2 weeks ago at the University of Pennsylvania. A similar type of presentation in which Marcel was the keynote speaker, and he was very emphatic about monitoring the variables and controlling the variables of animal anesthesia and for surgery, so that your data from your experiments can be valid and reproducible. And that's the same thing that we've tried to do as a company, Kent Scientific, for animals, because we know how important research is. And so we've made it a focus on our company to try to do things that are non-invasive and allow the user to, or the researcher, to control external variables in the animal. Thank you. It's been great to be with you, and we hope this has been of service.